Algebra 1, Chapter 3, Section 1, Graphing Linear Equations. So a linear equation is basically any sort of equation that is going to give us a straight line. So if you have some sort of graph, gives you a straight line, it was a linear equation. We can always write a linear equation as in something called a standard form. And the key here is that those capital A, B, and C variables, those are coefficients. The C is a constant because there's no variable attached to it. But we like whole numbers. We don't like any fractions or decimals. We prefer A to be positive, but it doesn't have to be. We also want there to be no common factors. For example, if I have 4x minus 6y equals 8, each of those a, b, and c values are all divisible by 2, so we're going to reduce that down to 2x minus 3y equals 4. And now we've got ourselves something in standard form. Now, of course, the 2 and the 4 have a common factor, but the 3 doesn't have the same factor, so we can't reduce it anymore. A big part of what we're doing here is not only putting it in this form or identifying equations that can be written in this form, it is also going to be identifying those a, b, and c values. So it is very important that the x term always comes first, then the y term, and then it equals a constant value. So from reading this, I'd be able to say a equals 2, b equals negative 3, and c equals 4. Notice there's no variables with any of them. Just by saying that I know the b coefficient in standard form is negative 3, I know it is being multiplied by a y. So we don't write it down. It's too much. So first thing we're going to do is we're going to try to identify linear equations and see if what we're given is actually linear. If not, we're not going to be able to write it in standard form. And then we just say it's not linear. Now for this first equation here, y equals 4 minus 3x. For standard form, I like the x's and y's to be on the left-hand side. So I'm going to add that x term to both sides. And because they're not like terms, I can't add them together. I just have 3x plus y equals 4. And if you take a look here, there's no common factor between the coefficients. It's got an x and a y equals a constant. We're good to go. That is standard form. And I would say, yes, this is linear. Okay. Now, for part B, 6x minus xy equals 4. So when I try to solve this and try to separate those x terms out, I'll notice I got a problem here. I have an x times a y. Whenever you have the product of two variables like x and y, product of x and y, if you see that, that should immediately tell you not linear. And if I were to try to put this in standard form, I'd have to factor the x's out, and I'd get x times 6 minus y equals 4. Well, that's definitely not standard form because it's x times another variable in there, and we don't want x times a variable. We only want x times a constant. But the big clue there was that x is being multiplied by y. It also is a problem if one of the variables is dividing by the other, or if you have an exponent other than 1 on any of the variables. All of those are clues to say not linear. All right. And same thing, you might also see a square root in something, any kind of root, not linear.